All right, so if you want to just start from the beginning. What is this? Grade 11 chemistry, unit 4, test review. Okay. All right, let's just do the question. Okay, let's go ahead. Oh, wait, this is not a question. Go ahead and read. So, what do you think? Yeah, you got it. Good job. All right, let's keep going. Close. So, a solution is saturated at 25 degrees Celsius. So that's saturated. But then when you decrease it, yeah, go ahead. So, okay, so then what happens is the warmer a solution is, the more you can dissolve stuff into it, right? Like if you have water and if I put sugar in it, if I warm the water, I can dissolve even more sugar. But then if I were to cool that water now down back to a temperature like cooler than what it was, at this point it's called super saturated because it's saturated more than it should really be able to hold at that temperature. So that's why it's called super saturated. Okay. Yeah, that's it. Yes, yeah. So the first solution is a saturated solution and it's 36.8 grams in 200 mils of water. And now the second solution is 19.1 grams in 100 mils of water. So how would that be an unsaturated solution, a saturated solution, a hypersaturated, or supersaturated? Let's find out. So what's the ratio? Like 36.8 over 200. Like what percentage is that? Just divide the two numbers and times by 100%. What do you get? 18.4. Just confirm. Okay, and the other one's 19.1. So which one is more has more of the solid? The second one. So the second one has more, and the first one was considered a saturated solution. What's the second one going to be called? Perfect. And just so you're aware, there's nothing that's called hypersaturated. That's just no. This is just a like a throw off. So the only three things are unsaturated, saturated, or supersaturated. Now, had this number been less than 18.4, then it would have been unsaturated. Does that make sense? And had it been the same, then it would have been saturated. So okay, ready to move on. So that was four questions. Let's do the next four. Go. So yeah, what do you think? So you have an ionic solution and then you have a molecular solution. Now, if you did a pH test, would that test the difference between ionic and molecular? No, you're right, because it has to do with acids and bases, so it has nothing to do with ionic. So, what about solubility test? Yeah, 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 that could work. What about test for saturation? Yeah, once again, that's not talking about like between ionic and molecular, so that's not definitely not that. So it's not definitely A or C. What about D, conductivity test? Well, if you have a solution with an ion dissolved in it, does it conduct electricity? Oh, okay. And if you have a molecular solution that's dissolved, would that conduct electricity? Okay, so I'll tell you the answer. So ionic solutions will conduct electricity, molecular solutions will not. So the answer is conductivity test because one of these ionic solutions will conduct electricity and the most molecular solutions won't. So that's the answer is conductivity test. So there you go. So now you know conductivity only occurs in ionic ions, not dissociation when you have molecular compounds dissolving. All right, let's keep going. Okay, is that the final answer? Because just so you know, polar molecules are here, polar molecules are here, and polar molecules are here. So if you think it's just B, that's fine. But remember, C and D also have polar molecules. So think about it. I think it's just B? All right, that's wrong. Try again. It is C, yes. Because ionic molecules are also polar. Just remember that. So non-polar molecules obviously not, and ionic molecules alone no. But the combination of A and B, which is C, yes. Because once again, ionic molecules are considered polar by definition. All right, let's continue. Seven. Oh, this is an easy one. Or is it? I'll be honest with you, this one's a little tough because I personally, without looking at the answer, I would guess this. It's definitely not hydrogen bonding because hydrogen bonding is just an example of that. But then if I were to think about it and realize that okay, ionic. So just so you know, intramolecular forces are ionic bonds, covalent bonds, and metal bonds, and intermolecular forces are dipole-dipole, hydrogen bonding, and London dispersion. So the answer is both of them. Both of these forces affect solubility, which, when I think about it, doesn't make sense. So yeah, yeah, that's the point. So intra meaning it's in English like there's a definition when it's intra and inter, one's between and one's within, something along those lines. I forget the English definition, but yeah, yeah, go for it. What do you think? Least soluble in water. What do you think? Silver acetate, possibly. This one's a little bit harder. So okay, we have lead nitrate, which is PbNO3, right? We have magnesium sulfide, which is like MgS. So it's probably not this one. This is pretty soluble, I would say, because it's an ionic, like Mg2 plus S2 minus, right? Lithium phosphate, which is PO4, so 3. And then silver acetate, which is AgCH3COOH. This one's a bit harder to explain, actually. I don't really agree with the answer here because I'm not entirely sure. But I would definitely knock off magnesium sulfide because that's a thing. That's just gone. And then lead nitrate, I would say is pretty soluble. So I know that. Um, I think what they're asking here for is looking at the solubility chart. You know that solubility table? So, yeah. Do you have the chart with you? You can take a look at it. Sure, yeah. Yeah. So did you yeah, check? I'll give it a hint. Nitrates are always soluble. It is, yeah. This is insoluble, right? So yeah, so just check your chart because you're going to be given that chart, right? So yeah, so we have that. So yeah, so there you go. So it wasn't a hard question then. It was just the one about checking. Yeah. Here you wanna depends on how much time we have. Let's move on to a few of the short answer type questions, shall we? Sure. Uh, okay, yeah, perfect. Right over here, number 22. And I'll upload this document for you, so you can just practice on your own. Yeah. No, of course. Okay, so let's do this. Go. Okay. What if the arrow? Like what goes on this side? You have to balance it, right? Yeah, you got it. Good job. And just don't forget the correct charges. Okay. All right. So yeah, good. And then what's your equation? Perfect. Yep. Oh, this is an easy question. Let me know when you're finished. All right, go ahead and read. Okay. What do you think? What's the solvent?